reaction mechanism, we must understand that every chemical reaction proceeds with many elementary steps which occur at molecular level. So meaning that there are formation of intermediate product before the formation of final products. Basically, there are two steps involved. The first one is the slow step, or also known as rate determining steps. At this step where the formation of intermediates. So we can also determine the rate law expression from this step. Secondly, the fast step. The fast step is where the intermediates is consumed to form a final product. And the sum of these two steps must give the overall balanced equation for the reaction. The elementary reactions in reaction mechanisms are classified in terms of their molecularity, meaning that we can determine the rate law for that particular step based on how many molecules or reactants are involved in the given step. For example, here the first one is unimolecular. In this case, we have one molecule involved to form the products, and the rate can be K times concentration of A. Secondly is the bimolecular reaction, where we have two molecules involved in the reaction A plus B to form the products, and the R can be K times concentration of A and B. The bimolecular reaction also can be the same molecule, for example A plus A, so the products can be the rate can be K times A to the power of 2. Thirdly is the thermolecular, meaning that the reaction involves three molecules A plus B plus C to form the products, and the R can be K times A times B times C. The rate laws for reactions are affected by the position of the rate determining step in the overall reaction mechanism. In this case, we have slow step followed by fast step. So the initial step here, the step 1 is the slow step, or also known as the rate determining step. So we have here NO2 plus NO2 producing NO3 plus NO. And then the intermediate form NO3 is consumed in step 2, where NO3 plus CO producing NO2 plus CO2. This is the fast step. So in this case, we can cancel out on both sides here with the same molecules. So what's left is for the overall reaction, we can just write NO2 plus CO producing NO plus CO2. The rate for this particular reaction, we can write here rate equal to K times the concentration of the reactants at slow step, or at the rate determining step, NO2 times NO2. And the order of the reaction here can be determined from the stoichiometric coefficients, where we have here 1 mole and 1 mole. So this one, the reactants is to the power of 1 on both of the reactants. So the rate will be K times NO2 to the power of 2. This is the rate for the overall reaction. Next, we have fast step followed by slow step. So the initial step here, step 1, is the fast step. So where 2NO producing N2O2. And then step 2 is the slow step, N2O2 plus O2 producing 2NO2. So overall reaction here, we cancel out the N2O2, so we can get 2NO plus O2 producing 2NO2. So the rate here should be, supposedly, we can get from the slow step, or the rate determining step here. So the reactant here, the N2O2 times O2. However, comparing with the overall reaction here, we only have oxygen, okay, but we don't have the N2O2. So in order to do this, we have to replace the N2O2 with NO, because we can get from here N2O2. 1 mole of N2O2 is equivalent to 2 mole of NO. So we just need to replace this one too with NO, so we can get the real, or the overall rate reaction for this is equal to K times concentration of NO to the power of 2 times O2. Another example here, when we have 4 elementary steps, which is this one is fast, slow, and fast reactions. So from this, we can cancel out the same compounds from both sides. The first one here, you can cancel out this Cl2 with Cl2, and COCl with COCl, and then you can also cancel out Cl with Cl, and then you can also cancel out this one. Okay, so what's left, you can have here CO plus Cl2 producing COCl2. Okay, now this is the overall reaction. So how to write the rate for this reaction? We can write like this, where rate equal to K times, we take the reactants from the slow step. Okay, so we put here COCl times Cl2. But then when we compare this reactant with the overall reaction here, we only have Cl2, but we don't have CO here. So in order to replace the CO with COCl, we can see from second equation here. Okay, from this, 1 mole of COCl is equivalent to 1 mole of Cl and 1 mole of CO. Okay, so we just need to replace the COCl. Replace this one into this one. So we can get the rate here, K COCl. Put here Cl2. And then later we compare again the reactants here with the final reaction. We have Cl2, we have CO, but we don't have Cl. So we compare again with the first one. Okay, from this equation we can say that 1 mole of Cl2 producing 2 mole of Cl. So if 1 Cl, meaning that we have 1/2 Cl2. So we put here K CO Cl2 1/2 and then Cl2. This one you can add together, so we can get here K CO Cl2 3/2. So this is the overall rate for this reaction.